All right, let's have a bit of a go at the parts per million conversion. Okay, so having a look at this is the worked example on page 349. So a saturated solution of calcium carbonate was found to contain this many grams of the salt. Okay, so we know that there is salt. We've got 0. Come on, it's not going to let me do the dot. Anyway, I'll just move on. 0.198 grams. Just try that again, that's slightly better. Grams of the salt dissolved in 2,000 mils of water. Now, the trick here, 1 mil equals 1 gram for water. So that's an important one to know. So if we had 200 mils of water, it would be 200 grams. If we had 1.5, it doesn't want to let me do the dots, does it? 1.5 liters of water, that would be equal to 1,500 grams. Now that's important because what we need to do here is we need to have the units here and here the same. So we've got 2,000 grams here. And so we've got 0.0198 grams per 2,000 grams. So we've already got it grams per grams here. And because the units are the same, we can cancel those out and we've just got a ratio. So once the units are the same, we can ignore the units. And so we've got 0.0198 per 2,000. Now we need to turn this into a million here. Now there's a couple of ways we could do that. How do we turn 2,000 into 1 million? Well, I'm guessing that we can multiply it. We could multiply it by, what do we have to times that by to turn that into a million? 500? Yeah, we could do that. So what we'll do is we'll times this by 500. And we know that with ratios, whatever I do to one side, I have to do to the other as well. Otherwise, the proportions don't stay the same. And so what I end up there is, this now is per 1 million. There we go. And all I need to do here is figure out what 0.0198 times 500 is. So we'll just wheel out the old calculator, 0.0198 times 500, and we get 9.9. So we've got 9.9 grams per 1 million grams of water. It could be 9.9 kilograms per million kilograms. It could not be 9.9 tons per million tons. Because the units are the same, they can actually be any unit or no unit at all. And so we can say that the concentration of the calcium carbonate in that solution is 9.9, there, it lets me do the dot then, parts per million. Fantastic. All right, now if you're okay with that, what we'll do is we'll have a crack at the next one, the try it yourself version. Of course, this would be best if you tried it yourself first and didn't just watch me do it. Have a go at the try it yourself at the bottom of the page first, and then I will do it in a moment. Oh, well, that moment's here already, so let's get on with it. Okay, so here once again, what we've got is we've got some salt. Whoops, I just used red. Got some salt dissolved in some water. Okay, well, we're told that it's water there. It doesn't matter what it is, as long as there's one thing inside another thing. Now we've got the salt and we've got the water. Yeah, no worries. And we can see here the salt starts off, we've got 0.0537 grams, and we are in 250 mils, which, as we recall, is the same as 250 grams. 250 grams. Okay, so that's salt per water is 0.0537 grams per 250 grams. No worries. Now, because we've got the units the same here and here, we can ignore them because, again, they can be any unit of mass. Yeah, mass. We'll stick with mass. All right, now, our job here is to turn this number into a million. And then we have to do whatever we multiply this by to turn it into 1 million, which I'll just put that there because that's what we're aiming for. There we go. Whatever I times that by to turn it into a million, I need to times this by the same amount, and then I will have my answer in parts per million. Alrighty, so without, we could use a calculator or you could just use your head here. Now, if I times it by 4, I've got 1,000. And if I times 1,000 by 1,000, I get a million. So we can use 4,000 as the multiplier here and 4,000 over here. Now, if you're not sure how to get that 4,000, what you do is you take the million and you divide it. It doesn't want to let me do the dots. And you divide it by the quantity that you've got, and you get the multiplier that you need to turn that into that. Neat little trick there. Okay, so let's take that. Let's wheel out the calculator again, and we got 0.0537, just pressing buttons here, times that by 4,000. And we get I'll use the same color here, 214.8 parts per 2148 per 1 million, and so the answer is equal to 214.8 parts per million, and I guess we should put NaCl after that, which I forgot to do in the previous one. All right, there it is. Parts per million, pretty straightforward. Parts per billion is exactly the same, except you've got another extra times by 1,000 here because there's another 3 zeros. Otherwise, that's exactly the same. All right.